Very good. Thanks, Marcus. And if you hang around long enough, you cover lots of bases. So I guess I was never smart enough to focus on one thing. So I was always privileged to have a position where if I found something of interesting, I could just follow my interests and go for it. Today is a talk which evolved from a consulting project I had a few years ago. And the lawyer was looking for people that had looked for subsidence caused by oil and gas production. And sure that I had three master's students that had worked in this area. And so I'm going to talk about the role of petroleum production on subsidence and submergence of Texas coastal lands. And I'm going to focus on the Rose City field, which is where the study was. And for you folks at the Bureau, the mapping studies were done at the Bureau 40 or 50 years ago, really provide key information. And so the stuff that the Bureau did really provides the basis for actually making many of the conclusions that I came up with. So let's talk about this. In Texas, all coastal lands that are below mean high water or mean higher high water, I'll tell you what that means later, which is interpreted as mean high tide, okay, and are tidally influenced, belong to the state. Corollary in that, all beaches below mean high tide also belong to the state. They are public. Yeah, but okay. There's a question about this though, because I came up with a different quote, Jeff. And Jeff, I'm sure you're probably right. You could very well be writing this, but yes, that's public. But what happens when the coast retreats? And what is now the beach below mean high tide is now under your property or maybe under your piers. And so there was a lawsuit about that, and the lawyers for the people in the house said, well, the beach, that's that beach that used to be 120 feet offshore. And that was turned down, and the judge said, and this kind of comes into what we're going to talk about here, well, if it happened in a hurricane, well, that's abrupt, then the landowner still owns it. But if it happened gradually or naturally, then the state owns it. I'm not sure where that goes, because with the lawyers, I'm not sure where that is. But that applies to some of the things we're going to talk about here today. So all belong to the state unless the sinking was caused by the pumping of subsurface fluids, oil and gas, or water. And then there was one court judgment that said, well, the pumping should be the sole cause. And I'll respond to that later. Well, to sink beneath mean high tide, what we've got is we have to look at the relative sea level change, and that is the combination of how much sea level is rising with respect to a datum. And of course, that land could be coming up like in California, or sinking as it is in Texas. We have natural subsidence, and then we have subsidence that's produced by pumping of oil and gas or water. And the combination of those things is what we call RSL, relative sea level rise. So it's a combination of eustatic sea level rise and subsidence that's natural, and that has been caused by man. Well, here's some estimates of eustatic sea level rise. You can see there's a number of people that looked at these things. Here's one, here we go. For the Texas Gulf Coast from 1909 to 1995, and he estimated about a little more than 1 millimeter per year. That's one estimate. And there's others, and one of the things we can see, it seems to be getting greater more recently. And here's this one by Lou, and here's his data. Now, he's only taken 1940, but his other data went back to 1909. And from that, going from 19 up to 1992, that's where he came up with the 1.1 millimeter. But we can argue about where that is and how you draw your lines, but it certainly is getting more now. What about natural subsidence and tectonics? Jeff, this is from your thesis. Late Pleistocene Central Texas Coast. Here's another one by another UT student, Winker. Here's one by Bob Morton, who used to be at the Bureau for Mississippi Delta Peats. Here's the Sabine Pass tidal gauge, Texas Gulf Coast. And we see we're looking at different years. But these are the rates which people have estimated is the natural subsidence, the consolidation of the sediments themselves. And probably if there's any tectonic settling, which is very slow, but is occurring. So what causes subsidence? There can be many, many causes. We're going to focus today on the extraction of petroleum, but there is natural consolidation. And I understand there's a project here at the Bureau. I hope you're going to get the data we need, because we need data. But there's natural consolidation. There's the collapse of underground cavities and dissolution. Maybe the collapse of some of the salt domes or some of the solution mining would be in here. There's natural tectonics. The Gulf of Mexico has been subsiding since the Cretaceous. There's vertical erosions by streams and wave action. We don't have hydrocompacting soils. Those are soils that are dry and you put water on, they collapse. And oxidation of organic matter, which people have talked about, but I haven't been able to find any decent data on it. Well, the Texas Gulf Coast is really well known for subsidence, and these are some of the classic ones. This is the Brownwood subdivision in Baytown, Texas, and that probably was even when they built it, was a couple $100,000 house. And this is the one, it sank so much that the Corps of Engineers said, we're just going to buy everybody out and let it sink. And this is one you've all seen, you know. Look at, it's funny, when they put this well in, it just jacked itself out of the ground. No, that's the ground is sinking because of pumpage of water. And you can see it's interesting how they have 1, 2, 3 concrete slabs. So had to keep pouring concrete under it. So it's well known in Texas that we've got lots of subsidence, mostly caused by groundwater. So what are these relative sea level changes? And here are some numbers, okay? One's for the Texas Gulf Coast. Here's Galveston Pier 21, and this has been influenced by pumping of groundwater. Here's Sabine Pass and tidal gauge near the area I'm going to focus on. And here are some numbers for the Rose City field. And you'll notice I've got different numbers on there. And the reason is we're not sure exactly when the subsidence occurred. We know between 1950 and 2020 how much is, and we'll show you that. But some of the Bureau publications, the Atlas of Submerged Lands, which would be a wonderful series by White and others, has come some numbers. Here are benchmarks, not over the oil field near Rose City, and they're, you're pushing a centimeter a year. And here's some other ones we're going to talk about. Are these out of whack? Could anything? Well, it turns out that the other closest oil fields are right in that range. And we'll talk about the Spindletop. Here's one by Bob Laux and Fred Wang. Bob is still here, but Fred is not. And here's one from the Port Neches field by Bob Morton, who also used to be with the Bureau. But we'll come back and talk about those in a second here. Well, here's the area we're going to study on, this area of around Beaumont. And here are some of the fields. Here's the Rose. There's I-10. Louisiana's just right over there a little bit. There's Rose City. Here's the famous Spindletop. Here's the Port Acres, Port Arthur field. And here's the Port Neches field. And we're going to focus in on this one, but we'll compare it to these. But the landowner, Mr. Arnaud, hired a very prominent surveying firm, and in the year 2020, they made a survey of his field. And they also provided some other evidence. They went back, and here is the pumping of oil, gas, and water from the Rose City field. Now, see a north unit and a south unit. Oh, that's kind of arbitrary. I'll show you what that is later. That's basically a property line. But this is showing the pumping rates. And they pumped a heck of a lot of gas, oil and gas and water, starting in 1950, and basically ceased flowing, and they shut the whole field down permanently in 2004. Here's the Rose City field. Here's Beaumont. Here's the Neches River. Here's the Rose City field in here. And this is from a 1974 topographic map. And this is all low. This is the 5-foot contour, but they didn't really survey out here. We had, in all the USGS maps, there was one spot measurement somewhere out here. We don't know where it is. But this is that old field. And note the position of Star Bayou, because that'll be a reference. It's interesting, some of these other things, these were canals, these straight lines here, here, that they put in when they timbered out all the big cypress trees back in the 20s, and or before even. But they mined them all out, and they took them out in boats, and so all the cypress trees were mined out in this year. So there's 1994. Here's the USGS map in 1994, mudflats. A couple of things, it's kind of interesting. Note, all through this thing, I didn't see any migration of Star Bayou or any of these canals. Those seem to be locked pretty much in place. And here's Beaumont, of course, down here. And here's a Google map from last year that I took, and you can see that this is still basically exactly the same. The only difference is this is a big gravel pit that they put in later. But you can still see some of the old roads in here, but this is that field. And the state said all this land that is underwater now belongs to the state. And the landowner bought it. Okay? Why would they want to do it? Turns out there are some reasons, okay? Has to do with money. Now, this is from White et al.'s Atlas of Submerged Lands in the Beaumont, and this was in 1987, and there's the Rose City field, and look at that's the exact same position where the water was in those previous slides. Here's the Port Neches field down here. So the Bureau, you guys said these are ponds, tidal pools, or shallow subaqueous flats back in 1987, but the data came in 1978. And there was one. Here is figure 64 of that one, and there's the Rose City field, and by gosh, it looks exactly the same, at least where they mapped it. So we don't know when that went underwater precisely, but certainly by 1987 or 1978, it looks like it was already tidally influenced and below mean high tide. Well, there was a lot of oil wells put in here. Here's that same city, and this is from the Shine report. And look at all these oil wells that were in here. So clearly, we must have data. Oh, by the way, this land, it's mean higher high water, because he got his grant from the Mexican government. And this was, I think, was probably his brother, and he got his grant from the state of Texas, so it's mean high water, but we call it mean high tide now. And the wells are produced here. That was the north unit. This was the south unit. But this is one oil field. Okay. What can you do without data? Well, it turns out Shine and Associates were able to identify 6 wells and well pads that they could find and survey. These are the 6. Once again, here's Star Bayou down here. And here's what they found. Well, these are the scout ticket right here. These are the scout ticket locations. And those are probably pretty accurate, because when you're going to be running downhole logs, you have to know where you are. That is their numbers. And then they surveyed those pads, and they had a high place where it was high. So here in this one was started, they think, in 1969, surveyed it in 2020, and it was initially mapped as being 7 feet above sea level. Some of it's 1 foot above sea level. Here's one that's about 4 inches above sea level. That's a mean here. But you can see, so if you add them all up, you're coming up with a subsidence rate of about, going to 2020, of 30, about a foot a year. Excuse me, a tenth of a foot a year. That's not centimeters, millimeters, excuse me, yes. Okay. I switched to centimeters per year there, okay. But so these are the numbers, and so we actually have data from a reputable surveying firm. And I said, golly, how could that be? How could it be so high? That just doesn't make sense, does it? Can it be that high? Well, that's when I looked at some of the previous studies, and these are the ones. So we're going to look at these other fields. So here's the Port Arthur's, whoops, excuse me, let me go back here. Here's the Port Acres ones, and this is by Wang and Laux. And what they did is they compared topographic maps, tracking the difference. And they had, for these two fields, which are adjoining, separated by a small growth fault, somewhere in a range of this many meters per year. And they came up, if you took the average of these things, about 48 millimeters per year. That's pretty close to the Rose City field. So maybe this makes sense. Oh, what about the Port Neches field? That's the closest one. And Bob Morton did this, and he had data from 1956 to 78. That field is still producing, but it started in 1929. So probably the highest rates of subsidence we would reasonably infer would have happened earlier in the year, or early in the life of the field. You drop the pressures, and those clays start bleeding out faster immediately and slower over time. But, given that, they still come up with, this much. If we look at Spindletop, that started in 1901, and Retzlaff from the U.S. Geological Survey, by comparing topographic maps, came up with ranges between about 30 and almost 90 millimeters per year, with the average of 58. There's a couple of things here. First of all, most of the subsidence would have been greater when they first started pumping the field, and they've also mined the salt dome, so there could have been collapse of the salt dome. But once again, these numbers are all the same. And Spindletop, we all know is famous. There it is. And there's the well field in 1902. So I suspect the subsidence had been greater earlier. But the point is, these numbers are all similar. Why are they so high? Well, maybe that's something we're going to figure out someday. But what about land directly not over the oil field? Once again, this is the field. There's City of Beaumont well, and here's one at the airport. I think these are pumping groundwater. But here are some other benchmarks that Shine and Associates got the data from. They didn't do all the surveying, but these are benchmarks that have been surveyed in. And you can see, looking at these numbers here, that's pretty high rates of subsidence. Now, if we throw out the two outliers here, the City of Beaumont, it averaged up to about almost 8 millimeters per year. We're not pumping a lot of water in Orange County. Okay? What could be doing it? I think it's probably depressurization of the oil and gas fields. One of your former colleagues at the Bureau, Charlie, and a number of co-authors mapped the Frio Formation wells. Okay, Spindletop is not, but the other three are all producing from the Frio Formation. And this would be hydrostatic. This would be overpressured. And these are wells. Now, this is for the whole Texas coast. But look at that. This is kind of like dropping the water level in a well by a kilometer. I mean, you're really depressurizing those systems. this is one footage just from the study area where we looked at those wells. And once again, this is the lithostatic, and we were doing some models saying if this was the initial pressure and this was the final assumed pressure, how much subsidence can you get? We're not going to cover that right now. But once again, there has been significant depressurization. Look at that. If those shales are not rigid, they're compacting. And that's why you get this high rate of relative sea level change, or subsidence in this case, at this field. So let's look at those. When did we have data? The production started in 1950, and we can say what happens. Did it, if you assumed a linear rate of subsidence from 1950 to the time that they surveyed those 6 well pads, you come up with 30. If it's to the end of the field, it's there. If you look at the USGS topographic map, it's here. If you look at the Bureau's report in 87, almost, 57.8. If it was the 1978 data, it's 76. So we don't know exactly, but these are subsiding really rapidly, okay? And this is my estimate. If you took at natural rates of subsidence and relative and eustatic sea level rise, you would say, if that is the case, 99% of all the subsidence, which causes submergence, was due to oil and gas production. And it was over this period of time, going to 2020, when, by the way, eustatic sea level rates are getting higher, it's still 95%. Well, are there any other possible causes? Let's look at them one by one. We could have natural subsidence. We've got eustatic sea level rise, pumping of groundwater, growth faults, lateral erosion by wave action. The state thought that was real important. Salt dome collapse, and maybe consolidation of soils after logging. These are the only ones that might apply in this area. Natural subsidence. Range from, according to Jeff Paynes, do I have it right, Jeff? Have I quoted you right? Okay, good deal. For the central okay. Yep. But up to the Mississippi Delta for the very youngest muds. Well, this comes up if you're talking between the end of, less than an inch. How much less, I don't know, but less than an inch. What about sea level rise? Well, if you take Lou's estimate of 1.1 millimeters per year, it comes up, inch and a half. That's not cause these things to be under sea level. Groundwater pumpage. This is an easy one. In the vicinity of the Rose City field, there's no pumping. Possible cone of depression could extend under the Neches River from Beaumont, but I've seen no data to look at that. But Orange County, they're just not pumping water. Growth faults. Well, this is one. I observed anyway, no lineations past, present of fault scarps in the area. And there is some limited data that maps that did not show the growth faults extending to the surface. Now, however, if there are growth faults and they got a permeability thing, they could actually control where the field is depressurizing the most. So if they had an influence, I think it'd be controlling where the depressurization occurs. But no evidence for that. Got to go with the data. Erosion by wave action. Couple of things. First of all, there would be no waves in this property if it wasn't underwater. It just, The other thing is, when you look, remember those aerial photographs and took, there was no expansion of movement of the Neches River, the bayous, or the canals were observed going back to 1943. So I don't see any evidence for that. Salt dome collapse. No salt dome under the Rose City field. This one, and people say, well, did you consider this? What would the ground have collapsed by 5 or 7 feet? You know, how many feet would have collapsed after you timbered and took out the cypress trees? I have looked high and low. I haven't found any data to substantiate that. As a tree farmer, my assumption would be that if you cut them down and the root mass and trunk decay, you could get local subsidence at that point. But I don't know how much you would get aerially on that one. So I see no evidence for that. So there are no other possible causes to cause that much subsidence. 0. So I can't say that the sole cause, this land is now submerged, is pumping of oil and gas. But I can say it's the only reason. No, actually, there are some legal, I found some legal connotations in that one. The landowner, the court decided, still owned the land. So the state did not get his land. But this brings up some questions. Texas law, water law, is still based on this one, Fraser versus Brown. And every student that took a class from me, I hope, remembers this. I love it. The existence, origin, movement, and course of such waters and the groundwaters, and the causes which govern and direct their movements are so secret, occult, and concealed that an attempt to administer any set of legal rules with respect to them would be involved in hopeless uncertainty and would, therefore, be practically impossible. But why is the land still valuable? Why would the state want it? Well, I can only come up with 3 things. Well, it's good for hunting and fishing, which Mr. Arnaud uses it for. Could there be, I suppose there could be future oil and gas there. But I think the reason is mitigation banking. Now, mitigation banking is when you are paid, well, in this case, Mr. Arnold was paid several $1 million by the Corps of Engineers for them to dispose of building waste and material waste that they had to put somewhere. So he used it to keep more of his land above water, and the Corps got rid of the stuff. They didn't have to dump it somewhere else, and he got paid a lot of money for it. Pardon? Okay. Yeah. And what about when they dredge the Neches River? I'm not sure if they're going to dump that on there. That's pretty polluted. Maybe they would. Now, the Port Neches field is also underwater. They have never, but that has never been used for mitigation banking, and the state was not interested in it. So I think the only rationale I can see is that would be money the state could get by the mitigation banking. Of course, that's a job. Yeah, Jeff. No. No, but I'll be done soon. So here's a non-lawyer's comment on the sole cause criteria. Very few geologic processes have a sole cause. I can't think of any. Like there's an earthquake, a landslide occurs after an earthquake. The earthquake caused it. Well, there have been earthquakes before and it didn't go down. What could have happened? Could there have been incision of the river? Could there have been construction? Could you get heavy rain overloading slopes? Was normal weathering changing the things? Yeah, you can't say that. So I think this criterion makes absolutely no sense But there's another one which is not in the law, but some of the judges use. It's called the but for, which means that but for pumping of oil and gas, this land would still be above mean high tide. And I think that's what the judge in this case ruled in favor of Mr. Arnold. And so a couple of things. Every place on the edge of the Gulf is going to be affected to some extent by rising sea levels. No question about it. So it's a beautiful area. This is some of those areas. Eustatic sea level is increasing. ESL's going up faster. And the coast, all these coastlands are going to be affected. They're all going to be affected. Subsidence due to petroleum production is occurring and should be considered. And in some cases, like the ones we've looked, it's certainly the predominant cause. Now, there's other people who have said, no, we don't get subsidence. I can send you papers in AAPG says, no, subsidence is not caused by pumping of oil and gas. Well, clearly that's wrong in this case. And now in many cases along the Texas Gulf Coast, we've stopped pumping groundwater, say, oh, we've stopped subsidence. But if you depressurize the oil fields, how long does it take for those shales to equilibrate? If they're thick, it could be decades or centuries. So they have not stopped subsidence in the Houston-Galveston area. It's still subsiding oil and gas, but at a very smaller rate and over a wider area. So that's something we need to look at. Now, we need more monitoring and research. We need more data. Those data that was supplied by, including people at the Bureau, really is really relevant. It gives us baseline data on which to make our judgments. So here are some research needs that I think we need to look at. Let's measure subsidence over the other oil fields. All those ones I showed with that paper from Wang and Anderson, we only have data on those 4 fields that I could find. There may be more, but we need more. And what is the areal extent and the timing of the depressurization of those oil fields? Now, one of my grad students, Dave Hill, was looking at these things, and in this area, he found that some fields, the virgin pressures, when they first developed, they were already underpressured, which meant that the depressurization from an oil field had extended over a larger range. We need those data. And how do the shale properties change with depth and location? What are the compressibility coefficients and permeability? We have some ideas. We've made models. I've made models, making assumptions in these things. But we need those data. And here's another one. I've only seen one paper in the Gulf Coast that even talked about secondary consolidation. Now, going back to your soil mechanics or my class when I lectured in consolidation, you have primary consolidation. You pump out the fluids, drop the fluid pressure, the effective stress increases, and the sediments compact. And for sands, that's mostly elastic. It may rebound, of course, if you repressurize it, but the shales, it's mostly inelastic. They don't rebound very much. But even after the effective stress stabilizes, those sediments continue to consolidate. We sometimes call it creep in the geologic terms. I've only seen one paper, and this has been almost always ignored, but in Montgomery County, it looks like they've made some measurements on that. So that's something we needed. And here's this other one. I said, I couldn't find any data on what happens, just out of curiosity, once you deforest it. Do soils really compact after you deforest in the coast? I don't know. So it's a wonderful area. And thanks to Ed Norwood, who introduced me to the law here. Nidra Thompson Foster, who was a top-notch coastal surveyor, one of the best in the state. Ed Arnold, the students. My former master's student, Steve Jeremy at Dave Hill Cave. And I wasn't Jeff's advisor, but I was on his PhD committee. and older studies by many others, including the BEG and Kreitler, Laux, Morton, and White, are just some that had some of the things. So it's a fascinating area. It's a real problem, and we still don't have all the answers. Okay.
Jack,
Jeff's got one.
your talk. Yeah. Just going straight to I'm just going to turn in my.
This is for all the grief you gave me during my dissertation defense. No, good talk. And an issue that's really important, in my opinion, anyway. Three things. One is, it seems like you could get an idea of a rate of aerial submergence by looking at historic aerial photographs that go back to the 30s. So that would be a good thing to do, I would think. Secondly, is there any chance that deforesting the area, taking out the cypress trees, could have caused a local increase in water level? It could have flooded, kind of like the sea in Australia, places like that.
So, I mean, because you'd be reducing the evapotranspiration.
Yes.
I suppose that's possible.
Yeah, you could have had a local depression in groundwater because of that. And my mind is blanking on the third.
No, that's certainly possible. But I look for data because I'm an old, I still have a tree farm, so I looked for forestry data. I couldn't find none on it, but yeah.
And the third thing is, it looked like the elevation loss that you established from the oil field itself was from pad elevations, from drilling.
That is one thing I'm not sure, but I suspect it was a pad.
Right.
Well, certainly it was a pad where they put it in. I don't know how much they raised the elevation of the pad at the time, but it was about, they're all about 5 feet where they had it. So they may have raised it a couple of feet, which means that the subsidence rate in the other areas might have been even more. Yeah.
And I'll have to add that Jack Sharp and I used to play handball a lot, and it was a great fun to go reserve our courts for sharp.
Yeah. And Jeff would always beat me 2 out of 3. Okay. Sue's got one.
That was fun. How deep are the amount of substance should depend on not only pressure depletion but depth. Yes, it should be. And some of these are really shallow.
Yeah.
I wonder if there's other causes, like about the dewatering. Some of that you talked about organics. If can those be eliminated as a cause, like the cypress dewatering, organic?
Yeah. Once again, I looked for data on that, but as far as I could see, the areas that were submerged or had water in them had been unchanged really up through 1974, and they mined those. They did those back in the 20s, so I don't know. The depth of the oil fields, it's about 4,000 feet, and so once again, Sue's right. If the depressurization occurs shallower, you'd expect a greater one because you get a kind of cone of depression. So I was surprised, and the Port Neches and the Port Arthur fields are also at about the same depth in the field.
I was listening to the Dutch last week complaining about Groningen field, which had subsidence.
Yes.
That's right. I may quote it wrong, but there's a lot of subsidence.
Yes.
For the Groningen field, and the Dutch issues. I don't think it was that low sea level, but still, that the cause they ended up shutting it in with a significant fraction of the gas resource remaining in it because of concern over induced seismicity, but subsidence burst Dutch farmers frantic, and that's a really deep field.
Yeah.
And make my question, because I think that's. I remember it's the Triassic.
Yeah. The Spindletop was a shallower field. That was less than 2,000 feet. Yeah. Well, isn't there a shale project going on here somewhere in the Bureau? I think we got some work to do.
Great talk. I've heard part of it before.
Yeah.
Hear it put together. A couple of things on Rose City. I've actually worked in that area that are interesting. They're very different
than some of the others. One is that it's down considerable depth. They say I remember about 9 or 10,000 feet depth to the producing zones, and the producing zones are fairly thin. And they're maybe 100 feet, not big things. Different than Port Arthur, which has considerably thicker reservoir, and of course, in the salt domes are almost another game themselves, and how they work. But what struck me in that is that it could be a thin reservoir over a fairly extensive area like that may give you more contact with shale, and allow depressurization over a greater volume of shale than a more compact reservoir, even if it had produced the same amount. The other thing I was curious about,
I think that's a reasonable surmise.
I have one of those, yes. I try. But the other thing I was curious about it, though, is that subsidence seems to be offset to the east.
Yes.
You really haven't seen it over the field itself.
Yes, and that also occurred in the Port Neches field. And so it's not exactly where the field is located, but where the depressurization occurs in the contact with the shales. And that's where I think where the growth faults could be saying, this makes a permeable pathway over here. And that could be, but we don't have data on that. But yeah, I think it doesn't always, now in the real shallow ones, like the Goose City, it's right over it. But when it's deeper, it can be broader and maybe translocated. Yep. We haven't solved all the problems in the Texas Gulf Coast.
Any more questions for Dr. Sharp?
Okay, thanks.
Thank you.